Balancing equations. We need to balance an equation because when a reaction occurs, atoms are not made, they're not destroyed, they're not changed from one type to another, so you can't change a carbon atom into an oxygen atom. What we've got to have, therefore, in our equation to show this is the same number of each type of atom on the left and right hand side of the arrow. Now, you've put your formulas in. You're not allowed to change your formulas. So if you want an extra oxygen, you're not allowed to just go, oh, we won't be O2, we'll make it O3. Okay, that's changing the formula. That's okay. Not okay. That is completely forbidden. What you can do, though, is change the coefficients. The coefficients are these big numbers up the front. And what that'll do is that'll double, triple, or in this case 5 times, everything that comes after it in that formula. So in this case, by putting a big 5 in front of that oxygen, we end up with 10 oxygen atoms. Okay? And we do that to make sure we've got the correct number of each type of atom on the left and the right.
Hello and welcome to Chemistry, Balancing Equations, Beginner Level. On your screen now, you see an equation. However, it is unbalanced because on the left-hand side, there are 2 hydrogens represented by the small 2 next to the H that react with 2 oxygens represented by the 2 next to the O, which react together to form on the right-hand side 2 hydrogens and an oxygen in the compound H2O, or water. Now this is unbalanced because although we have 2 hydrogens on each side, we only have 1 oxygen on the right side and 2 on the left-hand side. Now, the law of conservation states that we must have exactly the same amount of atoms at the start of a reaction as at the end of the reaction. So, we need to double the amount of oxygens on the right-hand side. To do this, we simply put a 2 in front of the compound H2O. This now gives us 4 hydrogens on the right-hand side and 2 oxygens. We have balanced the oxygens now, we have 2 on either side, but we have too many hydrogens on the right-hand side. We have 4 as opposed to 2 when we started, which means we would have gained 2 hydrogens from nowhere. So, to solve this, on the left-hand side, we simply put a 2 in front of the H2, which gives us 2 times 2 hydrogens, 4 hydrogens. And this is a completely balanced symbol equation. Another example, Na, 1Na, plus 2Cl react to form NaCl, or sodium chloride. Now, there's equality in the sodiums, 1Na on the left and 1Na on the right. However, there are 2 Cl's on the left and only 1 Cl on the right. Now, we need to double the Cl's, so we put a 2 in front of the NaCl. This gives us 2 chlorines now, giving us balance, but it also gives us 2 sodiums, which means there are more on the right-hand side than on the left-hand side. To counter this, we put a 2 in front of the Na on the left, giving us 1 times 2 sodiums, 2 sodiums. This is a completely balanced symbol equation, because there are 2 Na's on the left, 2 Na's on the right, 2 Cl's on the left, and 2 Cl's